All right. Good morning and good afternoon, everyone. Thanks for coming. First of all, everyone here and also on online, Zoom, YouTube, wherever. Today is actually a very special day for me, for my family also, because this is such a big dream for us. It's not that easy to study abroad and all these things, but the last 7 months or so has been extremely transformative, I would say. For that, I would like to thank my supervisors, like both of them. Hais is also here. Thank you, Hais, for coming. And also, like there are so many other professors like Sadar also, who was extremely helpful in the last Q5 quarters, and also like the robotics courses. So TU Delft has given me a lot, and this is like a culmination of everything that I've learned in the last 7 months and the time before that. So I see this as a shift towards something new. So everything that you see is something I learned in the last 6 months. Is something that I did not know before joining TU Delft, or not even last year. So join me. Let's see what I've done. So to just give a brief background on what the thesis is all about. So last February, like some few months back, I had gone for this conference in London, and then we were looking at a lot of presentations by big companies, which were tech forward and then advanced in digital technologies, where the common factor was that most of them had access to years of data. Like they had a lot of data which they have curated over a lot of years and decades. Then I started to question the whole notion of data sets, right? So the question is that while established architecture firms possess huge data sets of decades of proprietary plans and like images and whatnot, they are able to train their own AI models, they are able to make their own generative AI solutions. But now, what about smaller firms and smaller practices, or say certain firms which do not have like a large data set? That brings me to the question of how can we defragment this process and democratize data access so that everyone has equal access to AI and AI applications in future. For that, I want to now walk you through like a sort of like a case study, which is what the whole thesis is about. What we just saw about datasets is just like to position the thesis, but the thesis itself is about healthcare layouts and how do we use AI to generate layouts. So let's take a case study. Let's say like there is an example floor plate which is empty, and then if you go to like a developer, he might ask you to maximize the number of apartments on the floor. And then let's say a corporate office like say Google or someone might want the maximum number of seats in the floor. Or if you go to like hotel management, they'll be wanting the maximum number of rooms on the floor. But can we say the same thing about healthcare facilities? Because can we just directly mean that if we put maximum number of beds, does that mean we are meeting the requirements? Is it that simple? I don't think so. Why? Because let's see how the process of healthcare layouts are formed. So, given an empty floor plate, basically the medical planners start placing these large departments, and then inside these departments you'll have smaller clusters, and then they start forming the rooms and gets into more and more detail. So traditionally the loop goes like the architect creates layouts and it's shared to the experts for review, and then they give their revisions and then the changes, and then it's a cyclic process which goes on and on and on for like months and years depending on the scale of the hospital. This is quite rudimentary in today's world. So the problem statement that I've developed is that the current healthcare design workflow is hindered by inefficient manual layout revisions and fragmented stakeholder communication, leading to project delays and technical inconsistency that necessitate a more adaptive data-driven methodology. Leading us to the research question, which says, how can an AI-driven framework assist in translating unstructured information to compliant healthcare layouts to facilitate the design process and collaboration efficiency? So these 5 points are something that I would be touching upon regularly. So the 5, let's say they are the 5 main research areas. And these 5 are further subdivided or using three buckets like design, data, and intelligence. We are going to do a research on that. So this is just to give an idea of what connects where and how things are interconnected. And then that formulates the literature review, which was quite a lot, quite in detail. And all of these, most of them were new for me as well. So this research was quite useful in understanding and learning new topics that help the design process. Jumping into the design methodology, what I've devised is that for every project, there is always going to be a project brief. At the same time, there are these standards which healthcare designers use. These are internationally accepted data standards, and then there are multiple versions of it. So the one I've used is the International Handbook for International Healthcare Facility Guidelines, and these are internationally accepted. So from these, we are able to extract the area statement, the program adjacency, and also certain reference information. And then I'm going to formulate them into a data structure called graphs. More on that later. And then using the graphs, we are going to create pseudo or initial layouts. Now, these layouts are sent to the user or the human for validating them. At the same time, they are able to make changes to the layout. Now these revised or like the final layouts can be stored, then be able to create a neural network or create a new model which can create new or better layouts automatically. So we'll go one by one. I have created certain excerpts from the whole methodology, so we can go one by one. So initially, these healthcare guidelines were extremely hard to read, even for myself. For the thesis, each book is around 500 pages or something. So what I've tried to do is basically here capture information from the guidelines so that people can access it through natural language. So these are the handbooks, and information is stored in mostly text and images. But for quick access, we are going to export them as graphs, and then using an LLM, just like your ChatGPT interface, any user can just search in queries and then get their answers, get to know where that information is coming from. Now for the area statement, we are extracting the same information from the data standards again. So the area statement is provided in table formats. So we used computer vision to extract certain key information from these tables to store them again in graphs. The graphs are structured in multiple layers. So level 1 is about the department, which is at a higher level. And then level 2 is about the clusters, which is at a sub-level. And then inside that, we have the individual rooms that have the specific information on the total area, the circulation area, and the number of rooms. So all these are stored as graphs so that they understand, we can also understand the relationships between multiple departments. And then we are able to also generate like a combined area statement that is required for the project. So we have now the areas, we now need to know the adjacencies or where to place what. So for that also, from the data standards, we have certain information in image space, which is a raster image. So again, using computer vision, we are able to extrapolate the adjacencies from this. So what you see on the first image is basically, it's a level 1. Again, it's similar to what we saw in the area statement. So level 1 means at a department level. Level 2 is at a cluster level. So multiple rooms together form a cluster. And then in level 3, it's inside the cluster, how many rooms are there, what are the adjacencies. These are again stored as graphs, but the data structure itself is quite complex at this point. So what needs to be done next is to combine the areas and the adjacencies so that for every department and every room, we have a certain information about their location on a floor plan, what are the other departments that need to be placed beside them, and also the areas that are required. Now also, we also saw in the first image that we are able to understand the interdepartment relations. So therefore, now we have a larger cluster of multiple departments in a healthcare unit, which can be extrapolated on a project-to-project basis. What you see here is basically interrelationship diagram or like a adjacency graph, which talks about multiple departments. Same can also be represented as a matrix. Now, in hospitals, it's usually the case that it is multi-story, multi-level. For that, what I've tried to create is from the data set, we have certain requirements which are mentioned in text. Those are captured as multiple levels, and then we are able to pick and choose based on the requirement of the brief. I will show it later in action. Now that we have all the basic requirements like the design brief, we have the project specific area statement, the project specific adjacencies. Let's see how we are able to create like a first draft layout, for which I have used cellular automata. It's basically a cell based solution, so it works on a grid by grid level. So just to make you understand what we have done is like we created like a 8 by 8 grid. On that, we are mentioning where the cores are located and where the courtyards are located. And then we are marking them as negative cells. So the solver will not be able to place any department in these black zones. And then what cellular automata does is basically it puts a first seed. Right now, it can be anywhere in the unclassified or valid cells. And then it starts looking for certain areas where all can we place a department. Now, once it has identified this domain space it can capture, it starts to pack these required departments. So what you see is 5 departments working on a 8 by 8 grid with a core in the center and a courtyard on the top right, or like an open space on the top right. The other thing to note is that the cellular automata also enables us to give a lot of rules, which basically means that I can constrain the dimensionality of the individual departments, so X by Y. I can also constrain it to be first attached to the periphery. So there are multiple rules which basically governs this layout. This is just a sample what we see here. I mean, when a project comes, there will be multiple departments, multiple floors. What you see here is just one floor with 5 departments. And then we dive into level 2. So this is the one that you saw is just departments, and these are sub-departments with clusters. Inside that, we start populating the rooms. So this is going to help us fasten the initial design process where you go from project brief directly into design without much tweaking. So the users are able to directly input the X by Y of the floor, mention the core location and also the courtyards if any, and then they're able to directly generate a layout that is following the guidelines. Use the word following guidelines because it is definitely not a validated plan because there is no human in the loop so far. So now the system is able to give feedback to the users through a validation methodology, which validates the layout against the input requirements. So here we can check visually saying, okay, there is a requirement of 110 square meters, but then it has provided 130 square meters. So there is an area check, there is a adjacency check, and then there is also like a room placement check. So these are critical informations that the users will need to create the layouts that they want. So now with this, we are able to extrapolate multiple layouts. That's the whole idea. Now we are able to extrapolate the graphs from this. And then now we are able to create a pseudo data set or a synthetic data set, which are human validated. Now, this brings us back to the first question that I said, like, what if there are small firms which which do not have access to large data sets? This is one way where they can actually create synthetic data sets to train a new model, which are human validated. Then once the model is trained, what it looks for is basically the hidden adjacencies. Basically, the input graph that you see here, the green lines are the only ones coming from the input standards, whereas the machine learning part can also see over a lot of data points, like say thousands and thousands of plans. It's able to make sure that there are other adjacencies that are discovered that may have been missed out by the data set itself. So all the yellow lines are something that the neural network or the machine learning is able to decipher. Now, once we have that information, we are able to fast track this even better. Now we are able to create better and more validated layouts because we have a large data set. These are some of the exports from the machine learning model. I'll quickly now show you something that is actually more important. So if I can switch over to this, yes. So what you see here is basically a live web app for the same process where we have multiple inputs, multiple uh, domains that the users can access. So I was discussing about the accessing of the raw information, text information from the PDFs. So this is in data science or like computer science, it's called RAG. So it uses a RAG system to basically extract information from large PDFs. So then you are able to you view the area required for all the departments. So what is the area required here? And then you're also able to visualize the layouts, the adjacencies, what goes beside what, and then the inter-department adjacencies, which we just saw, and also the flow stack. The flow stack, the users are able to add or remove on the fly, and then the layout gets updated as required. And then in the layout designer, the user is able to select the required areas like the size of the core, the location of the core, and then when they click create layout, it automatically populates the floor plan. Here, they can directly check if the validation is right, or they are able to select and then view different parts of the layout itself. So right now we are looking into one of the departments, and then these are the 5 clusters, and then these are the 4 rooms inside one of the clusters. If required, the users can also move or like scale based on the requirement. So they're able to make changes to this. And also the added advantage is that they can validate this, and then the model is able to return critical information which talks about the adjacency requirement and also the area requirement. Beyond this, they are able to export this to Rhino. So through a JSON file, they can export it to Rhino, or they can create a GraphML file, which further trains the model. We can make more and more data points and then improve the performance of the model. Also, they're able to export PDFs. This is standard exports. And yeah, that's mostly the project that I wanted to show you today. This was my thesis, and I've tried to cut short on so many points, but this is overall what I wanted to say is like the 5 key areas that we discussed. Again, AI-driven workflow, translating unstructured information, which is all the raw information from the PDFs, compliant healthcare layouts with the human-in-the-loop process, and also facilitating the design process and collaboration efficiency. That's Thank you. Questions? Yeah, I think right now it's just focusing on one aspect, which is the design aspect. But then over a period, you can add more and more features or like parameters to it to make it more validated. So as you say, maybe there can be a structural layer which talks about certain distances between columns and whatnot, which are automated in a systematic way, so that if the user chooses, let's say, 10 meters column to column, then it will already flag it, and then they can change the design again. So the idea is, as you say, like the idea is to improve the design process also, as well as give enough resources and like tools to the user design on the fly. It shouldn't be like they should go back to the review committee and then come back. It's a long process. So we're trying to reduce that. I think the at least for the chat interface and like extracting information, I've given it like a verbatim response, so it doesn't hallucinate at all. So it can only extract information from the PDF word to word and then give the information to the user. Although in future, I think there might be a requirement where users might want to learn more about a certain topic. So as you say, there should be some amount of leniency, like through guardrails. But at the same time, the information that it finds from the PDF should be word for word. It cannot be, interpreted, because these are standards, and interpreted standards can lead to different designs, maybe catastrophe also. So the idea is to just stick to the PDF for now, then expand later. And the other thing is that everything is running locally. None of it is using an API key or something. So for architecture studios, it comes down to like critical information sharing with other companies. So it's mostly NDA. Everything is under NDA. So running these locally actually is an added advantage in that sense. Thanks. Yeah. Mm. Yep. Yeah. Hmm. Hmm. Yeah. Hmm. 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 I think it's what you see is like a hybrid graph. Like it does talk to other nearby nodes, but not after it goes beyond the level 2 information. So by level 2 we are having multiple duplicate names. So let's say examination room might also be there in another department. So by linking the same level of information, the departments might get confused as to how much area they might require. So right now it's structured as a tree, but then on a level 1, which is at the department level, they are still talking to each other. Yeah. Any more questions? Mm. Yeah. I think that's like a common understanding with LLMs or like with AI models in general, is that over if you change what is the input, then probably you should retrain, and then, but overall the workflow would be the same. You might have to retrain or like give it new information and remove the old information, because there have been instances where feeding new information, but if people forget to delete the old one, or like the LLM still remembers certain parts from the previous data set, so it gives partial information from the wrong one. So we still have to work on those aspects, but it's totally possible. Yeah. Mm. Yeah. Mm. Uh, at the start, when I did start the project, like it is quite hard coded in the way it is extracting the information. Like for example, the layout extraction from the images, because it's a raster image, there is only a certain thing I can do to extract information. But later I discovered that for LLMs and for AI to do better work, like to be less or to be more optimal, then probably it's a good idea to convert large information into markdown files or like HTML files, so that the standardization happens at the start, and then the LLM starts working in the process. So right now the workflow is set specific to the document. Instead, if we change if we add like an intermediary layer which converts that into a standard format, then the process can remain the same. That's like one of the ideas. I mean, there are so many ways to do this, I guess. Yeah. It's primarily the designer, like the medical planner, but it can also be clients who are like the medical experts who want to review the plans or review the layouts. So the idea is they also get access to certain information, like a sub dashboard of sorts, where if they want to make changes or like make annotations, they're able to do it on the web app. And then while they're doing it, they're able to validate the layout. So it's not like they need someone them the right information again. So it's not this, I'm trying to avoid the cycle. Instead, they're getting information then and there while they're editing the layout. Currently, it's in space, so it's also from scratch. So they're able to define the layout, size, the core locations, and whatnot. But for like maybe the medical expert, it'll just be certain tools like say move, rotate, or like scale, but then they are not able to change the whole layout itself in that sense. So we can still put them inside a container space so that they're not able to edit too much of the original layout. Mm. Yeah. Probably the next steps would be to like, yeah, it can be added, but for now, I think in the idea to expand this would be also to incorporate like say climate into this. I'm not sure because I really don't know how we can capture that. I also like multiple times Mikhail and I were discussing about the same aspects of like the soft parameters of like a healthcare layout. But then I think get this data into a structured format was one task, but to also bring in certain information which I don't have access to is something I didn't know what to do exactly. My role, my role is like the developer role right now. Right now, the next ideal step is to get feedback from users and see if actually it's useful for them. Then incorporate maybe more features or remove features if it doesn't make sense. And technically a developer at this point, I feel. Thank you. Yeah. Mhm. I think so too, because right now it already deals with multiple levels of floor layouts, but it on a by one. It, level, right now it can still do multiple levels one by one. But then the next step would be to take it further to make thing out of it or like understand spatial volumes out of this because develop the and then build on the massing or like can be both ways, but it's usually once you have the layout fixed then you're able to make some minor tweaks to the volume itself. Mm. So the one of the features that I implemented towards the end is that not every brief is the same, not every site is the same. So so if the floor plan size reduces, then it starts to pack it vertically. So it still understands the vertical relationships because it's, yeah, yeah, kind of. It's like an intermediate layer. So it knows what is above it. So it can also split certain volumes. So for example, if is so big for a floor plan, it can still divide that into two and stack them vertically if required. So these are rules that are already baked in for each department, whether they can split, whether they cannot split, whether they need to be on the ground floor. So these are some, I think the capabilities are still like can expand much more than what I've done. Uh, why I say this is because the climate also plays like a major role in placing certain departments in a certain location, right? So in that sense, the obvious next layer would be the climate layer or like access to daylight primarily because, for example, the inpatient units or like the care units should technically be daylight. Is that we can store those information for a specific department in that node itself, then the solver takes all that into account while placing the right. uh, every project still needs some level of confirmation from say the medical also, because they have a lot of say in the layout support tool, not like an automated tool, although most of the parts can be automated to that extent. Yeah. No, I mean like, yeah. So the idea of developing this workflow is to first create a data set, right? So the data set itself is non-existent at this point. So once we have a data set, the machine learning model can develop better and better layouts. But then the ultimate validation still has to be done by a human or the medical expert. Yes. 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 Yes, it's a decision. The ultimate decision is by the human, but probably we don't have to sit and design. Okay, this is what comes here. We don't have to do much of the the, the heavy lifting. We just need to see and review certain layouts and understand. I think existing. So, for example, there are a lot of data sets available for residences and like commercial spaces, but they don't we don't find much for like hospitals. We don't much find for like say airports or like these critical infrastructures, right? So so this becomes like a solution to fast track that process of or like bridging that gap, so that we are able to develop a better better design output out of this. That would be the novelty in this, I feel. Yeah. want like missed out like or say how the layout is designed in the start itself. Maybe there are better ways of doing the layout itself using the graphs. So probably I would spend, if I'm a scientific wants to continue on this, would probably more time on understanding how graphs can be converted into layouts, because that research is quite new, not researched that much. So probably using graphs to create layouts on a global level, not just healthcare. It can be any layout. So that would be like most likely the scientific direction. Um, Probably how can graphs be utilized to create layouts in the most efficient way across typologies, probably. I think I just wanted to probably thank everyone who supported me on this journey, and then it's been quite emotional 2 years for me away from home. All the hardships that I have went through to be here, and then now that this is happening, I'm probably I am the first. So that will be a new thing for my family as well. So everything is quite emotional at this point, but I am genuinely grateful and happy for everything. Yeah. Yeah. Thanks. Thank you. Oh, okay. Good then. Okay. Okay, this is to confirm that it is. Okay. Okay. That will come soon, I think. Thank you. Yeah. Yeah. Thank you.